Today we are talking about chatter monitoring. Chatter monitoring is a software package from Vibration Research that can be used to monitor how many chatter events occur inside of a particular test. Chatter events typically are characterized in two different ways, either as bounce or a discontinuity. Bounce typically occurs when too much current is applied to a magnetic coil, which causes the coil to chatter. The other type of event is a discontinuity, and that's what we're mostly concerned with today. Discontinuity in our case is where the spring tension or electromagnetic force of the relay is overcome by vibration. So the result of that is a chatter event where that vibration causes a disconnect between the two terminals on the mechanical relay. So what you can see here is I have a basic circuit laid out, and it shows my relay configuration on the left and how everything is connected to the 9500 in the middle and on the right. For this demonstration, we have a 24-volt coil relay with two normally open and two normally closed contacts. Now, normally open, normally closed describes the resting position of the relay when it is not energized. For this demonstration, we will run a typical seismic test that has been modified to be able to run on an electrodynamic shaker. In order to configure this appropriately, I need to measure a fixed signal coming through my mechanical relay. And I do that through a power supply that's generating 5 volts. With that 5-volt supply, I have it fed through into the common terminals of my relay. And the 4, so 2 normally open, 2 normally closed terminals are connected to channels 5 through 8 of my secondary controller. On the primary controller, I have a control accelerometer that's mounted on the armature of my shaker, and a triaxial accelerometer mounted on the end of the relay, so we can see approximately how much acceleration is being experienced by the end of that, or at the end of that relay. So to start, open VibrationVIEW, and we'll start with the Sine Sweep. If I edit my current test, this is the test that I have set up, we have a Sine Sweep that will sweep at 15 G's peak from 20 Hertz to 15 G's at 500 Hertz. Our test schedule, we're going to modify, rather than just doing a simple sweep down, we'll insert a second level, and once you have the chatter monitoring package enabled on your controller, at the very bottom, you will have a chatter table option to add into your schedule. This means at the end of the test, it will automatically generate that chatter table. Also, when enabling the chatter package, or once it is enabled on your controller, you get the chatter tab. The chatter tab is where you enable or disable chatter monitoring. Now, this can be done in conjunction with a live test, or it can be done post-process. What that means is VibrationVIEW is not processing chatter events as they occur throughout the test. What we're actually doing is recording the file, recording those waveforms, and at the end of the test, processing that waveform and looking for chatter events that meet certain criteria. So in the chatter tab, I enable chatter monitoring, and in this case, channels 5 through 8 are my potential channels for chatter to occur. I know that channel 5 transitions to channel 7. What that means is a transition is between that normally open and normally closed contact. If halfway through my test I want to energize the coil of my relay and then run another pulse or another sine sweep, I need to tell VibrationVIEW that that transition is going to occur. And what it will do is automatically throw that out, not counting that as a chatter event, but labeling it as a transition. So channel 5 would transition to channel 7, channel 6 would transition to channel 8, and we'll do the reverse of that. So channel 7 to channel 5, channel 8 to channel 6. Next, I have contact type. For contact type, I can select auto, normally closed, or normally open. If you want to define what type of contact that is, you can define it, or you can leave it at auto. The next 5 boxes can either be set individually or as a whole group. And I do that at the very bottom. All channels use a criterion of milliseconds. This is how long of a duration chatter event has to occur before it constitutes a failure. In this case, I have it set to 2 milliseconds. So chatter events less than 2 milliseconds will be recorded, but will not be marked as a failure. Only those equal to or exceeding that 2 millisecond point will show up as a failure. Next is my high and low levels. I'm using a simple 5-volt supply, so 5 volts is my high level, 0 volts is my low level. Threshold percentage. Threshold percentage is how far increasing or decreasing that voltage must move in order to be counted as a chatter event. So in this case, I have 20%. Finally is the frequency, or DC. That means if I'm in the United States, I would expect the frequency of an AC signal to be at 60 hertz. If I'm in Europe, it would be 50 hertz. If you're using a variable frequency drive, it could be a variety of things. This is a custom entered value. We do have some predefined frequencies in there, but you do not have to use them. In today's demonstration, I'm using a DC power supply, so I'm going to select DC. The other tab, test tab, that comes with chatter monitoring is the ranges tab. Ranges is where you set the various time ranges that the chatter table will classify chatter events in. We'll see that once we run through the test and have some actual chatter events to observe. So I click apply and I can start my test. As the test comes up to level, we'll start at the high frequency and sweep down. So now that our test has completed, our initial sine test has completed, that recorded file is evaluated, and we have a chatter table that is generated. What you can see is that I had 1,613 chatter events, each individually picked out and displayed. I had 7 that ranged from 4 to 8 milliseconds. With that, I can then copy the table, I can copy the different transitions, I can copy events, I can copy graphs, and bring that directly into a report. Now, this doesn't necessarily have to be done after a test profile has been run. If you have time history files, we can analyze those time history files post-process and open that to view that chatter table. I would do that by clicking Edit Test, going to the Chatter tab, and selecting the Evaluate File button. Evaluate File is going to allow me to open a recording. If I open one of the recordings that I did recently, this particular run, you can see, is different from the previous in that I only had 5 events in that 2 to 4 millisecond range on channel 5, 4 on channel 6. The next type of test that is typically run would be an SRS type test. This is a long duration shock pulse. With that long duration shock pulse, it would most likely be one of the earthquake environments. Again, because I can't run an earthquake test on this particular shaker, I have a different profile created. This is a 5-second long SRS pulse. If I edit my test, you can see my SRS breakpoints, my synthesized waveform. On the chatter tab, if we enable chatter monitoring, again for channels 5, 6, 7, and 8, set our transitions. Click OK. The only requirement for chatter monitoring is to ensure that recorder view is enabled at the start and stop of the test. If I did not want to see the chatter table, but I wanted the option to evaluate it for chatter events down the road or in the future, what I could do is go to View, Recorder buttons, my test settings. I want to record at as high of a sample rate as I can. Select the channels I want to record, which in this case are channels 5 through 8, and check the start and stop recordings at the beginning and end of a test. Now, when I click Start, I can start my test over. The test will come up to level, and I can monitor those chatter events in time in my voltage versus time graph. So now my recording is completed. I haven't generated a file or I haven't generated a chatter table, but I can visually see that I have a lot of chatter events occurring in that voltage versus time graph. If I wanted to evaluate that file, again, go to Edit Test, the Chatter tab, Evaluate File. In this case, pick my last recording and open the waveform. Here I can see that I had 42 less than 1 millisecond, but I did have 3 events in 2 to 4 milliseconds and 5 in 2 to 4 milliseconds respectively. So I can see those chatter events. From there, I could copy the graph, paste it into a report, and generate that report that in the end is the goal of running the test.